Good morning everybody. This is our seventh video of chapter 2 metals and non-metals. In the previous video we have discussed about metallurgy and the processes of concentration. In this video we have discussed about the second type of process, that is, first process is concentration of ore and second process is conversion of ores into oxide form. Some ores are found in nature in sulfide form, and for example, if it is written as zinc sulfide or zinc carbonate. Another example, it may be copper sulfide and carbonate ore. Copper carbonate, if we take the example, first we change these type of oxides, sulfides, into the oxide form. There are two processes related to the conversion of ores into oxide form. First one is roasting. Roasting means heating of, or you can say that strong heating of sulfide ore, or you can say that strong heating of ore in the presence of oxygen or in the excess of oxygen to convert into its oxide form. But this process is basically used for sulfide ore here. So the roasting is strong heating of sulfide ores in the presence of excess of oxygen to convert into its oxide form is called roasting. As you know, the word roasting is used for strong heating. So strong heating of sulfide ore to convert it into oxide form is called roasting. This process is very important for your board exams. For example, if you use zinc sulfide plus oxygen to form zinc oxide plus SO2, sulfur dioxide gas is formed in this process. If it is again make reactivity series: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, and so on. So hydrogen, copper, mercury, silver, gold, platinum. So as we go from zinc sulfide, ferrous sulfide, lead sulfide, copper sulfide are undergoing this process for changing this sulfides into the oxide form. First you change the sulfide into the oxide form. If we take the example of HGS, cinnabar, HGS, the reaction is further going on. HGS is converted into HgO plus SO2, and then it is also heated. Heating is here, so heat again. This heating process is continuously, and mercury is obtained from this roasting. So direct roasting of mercuric sulfide into leads to the separation of mercury from mercury sulfide. Likewise, copper sulfide, if it is cupric sulfide, cuprous sulfide, Cu2s, here valency of copper is 1. So if it is cuprous sulfide, by the action of oxygen, strong heating of cuprous sulfide, this is cuprous sulfide in the presence of excess of oxygen leads to formation of Cu2s along with Cu2O. Cu2O is found here, and Cu2s is also present here. So the reaction proceeds and becomes Cu plus SO2. In this way we can obtain copper metal by roasting of cuprous sulfide. Next process is calcination. The second process is calcination. As the word indicates, calcination process. In this process, mostly carbonate ore is heated in the absence of air. In the absence of air means there is no need of oxygen for adding oxygen to the ore. So this process is used to convert carbonate ore into oxide form or any type of ore which has volatile impurities. So we can say that strong heating of ores in the absence of oxygen to remove their volatile impurities. It's called calcination. Or you can say that in some books the definition of calcination is written as strong heating of ores in the absence of oxygen to convert carbonate ore into its oxide form. That one is also correct, but the more correct definition of this calcination is, this calcination process is done for the removal of volatile impurities. This is volatile impurities. First understand what is volatile impurities. Volatile, if the ore is carbonate ore, for example, if it is calcium carbonate, zinc carbonate, when you heat these two, we know that by the thermal decomposition of calcium carbonate and zinc carbonate, we know that when we heat these two, strong heating of these two leads to the removal of carbon dioxide. So calcination process is removal of carbon dioxide from carbonate ore, means strong heating of carbonate ore in the absence of oxygen to convert it into its oxide form. Calcium carbonate changes into calcium oxide and carbon dioxide is released. Likewise, zinc oxide is formed with the liberation of CO2. But there may be sometimes calcium sulfate, zinc sulfate or ferrous sulfate also. We can obtain these type of ore also from the earth crust. To remove, by heating these three, we get SO2 and SO3, as we know that when FeSO4 is heated, then Fe2O3 plus SO2 and SO3 is formed, as we studied in the first chapter and first chapter, the thermal decomposition of sulfate. By the thermal decomposition of ferrous sulfate, we obtain ferric oxide, means this ore, we can get this ore into oxide form with the removal of what impurities? Volatile impurities. SO2 and SO3 both are volatile. Likewise, carbonate, from carbonate we get CO2 impurities, CO2 impurities. So, the exact definition of calcination is a strong heating of ores in the absence of oxygen to remove their volatile impurities. So, you must understand and remember the perfect definition of calcination. The calcination is not only conversion of carbonate ore into oxide form in the absence of oxygen. Calcination. So, to remember the word calcination, you can use the calcination is heating of strong ore to convert carbonate ore. C for calcination and C for carbonate. But sometimes we also use this process to convert sulfate or nitrate ore into their oxide form. So, examples are, as examples given in your book is zinc carbonate. Zinc carbonate. Strong heating of zinc carbonate. In the absence of air means there is no need of addition of oxygen. So, zinc carbonate means zinc oxide plus carbon dioxide. We can get zinc oxide by this process. We can also use calcium carbonate, calcium oxide plus carbon dioxide, magnesium carbonate, magnesium oxide plus carbon dioxide. By this process, a volatile impurities like carbon dioxide is removed. By this process, carbonate ore is converted or can be converted into oxide form. Then here is a question that what are the difference between? Write the difference between. Differences between roasting and calcination. It is of 3 marks question and it is very important, very important for your board exams or any exams. The periodic test is yet to come, so on 26th June your science paper is. So for this, the first and second chapter is given in your question paper. So prepare both the chapters. All 3 chapters are interrelated. In this chapter, metallurgy is left. Other than metallurgy, all are done. So you prepare carefully for your examination. So there is a question, write the differences between calcination and roasting. What is roasting? Heating of ore in the presence of excess of air, excess of oxygen, and here heating of ore in the absence of air. This is the basic difference of these two. So write the difference between these two in your homework. After converting into the oxide form, the third process is reduction. before going to the reduction, I once again draw the reactivity series. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, tin lead, you can say tin lead, hydrogen, copper, mercury, silver, gold, platinum. I think you remember it. From potassium, sodium, calcium and magnesium, these five up to aluminum, these five are highly reactive metals. So these five cannot be reduced by carbon, but by using carbon we can easily use carbon for reduction. Carbon is cheaper than hydrogen, so we can use carbon for the reduction of these metals from their metal oxide. Reduction of metal oxide to get metal. For the reduction of metal oxide, first we use carbon, as we write here. First example is zinc oxide. We cannot use carbon or hydrogen to remove calcium from calcium oxide. For removing calcium from calcium, for extracting, we can say that for extracting calcium from calcium oxide, we use electrolysis process. For this, electrolysis process is used. Electrolysis. But for zinc oxide, we can use carbon. We can reduce zinc oxide from carbon to get Zn plus Cu. Here, there are something to observe. Carbon monoxide, carbon dioxide, and we say that SO2, SO3 gases, these type of harmful gases are ejected out from the metal industries. To absorb that type of metal industries, the industry maker, the entrepreneur or the industry maker like Tata, first plant many number of trees, thousands of trees in their industrial area to absorb these type of gases, these type of harmful gases, sulfur dioxide, carbon monoxide type of gases are evolved or ejected out from the metal industries. So it is very necessary to plant trees if you are going to plant this type of industry. So first is zinc oxide. You can use zinc oxide for the reduction of, and we can use if it is PbO, lead oxide, we can use carbon for the reduction of lead oxide also, Pb plus Co, or sometimes CO2, CO, CO2. CO2 is formed, CO2 is formed. It first converted into carbon monoxide and then it is converted again into carbon dioxide. So by this processes we can convert metal oxide into its metallic form, and after that we can refine the metal from it. We refine the metal by electrolysis electrolytic processes. Here we can also use, for the reduction of these two, we can also use, in some books there are zinc oxide plus hydrogen. So we can't use reduce hydrogen from zinc oxide. In many processes, the hydrogen is used for the reduction process to remove this oxygen from it. For example, if it is copper oxide, then CuO or CO2O, whatever it is, copper oxide can be reduced by using carbon, like Cu plus CO2 or CuO plus hydrogen, Cu plus H2O, water in the form of water vapor can be used for the reduction process of copper. Next is reduction of metal, and next is refining. I will discuss the refining process, electrolytic refining of in the next video. In this video, let's discuss some different type of reduction. Like if it is HGO by strong heating, it converted into Hg plus O2. Reduction process is done in this way. So we can say that only roasting is done here, only heating process is done here, like Ag2O, heat it and it converted into Ag plus O2, because these two are least reactive metals. So after heating, there is removal of oxygen, and we can use this process for obtaining silver or mercury from their oxides. Thank you.